Hello, everyone. It's Mr. Kissinger at Citizenship Academy in Syracuse, New York, and this is 5th grade math module 5, lesson 4. We're going to use multiplication to calculate volume, so we're going to move away from that more visual model and start to kind of get into more of a standard algorithm for calculating volume. So let's look at number 1. It says each rectangular prism is built from centimeter cubes. State the dimensions and find the volume. So we're going to look for the length, the width, and the height. The length is going to be this dimension here. The width is this dimension here, how wide it is. And then the height is this one here. I'm going to draw that a little bit better. The height's right here on the side. So our length here, I'm going to do a kind of a cursive L there for length. We have width, we have height. Our length is 1, 2, 3, 4, 5 centimeters. Our width is 1, 2 centimeters. And our height is also 2 centimeters. So we're looking at 1, 2, 1, 2, and then 1, 2, 3, 4, 5. So we have 3 dimensions there. And we could look at it like we were before. We could look at it like layers, and we could say, okay, there's 4 in this layer here, like this is like a slice of bread. And we could say there's 4 in this layer, and we have 1, 2, 3, 4, 5 layers, and that would give us 20 cubic centimeters altogether. Or we can take 5 times 2 times 2, and 5 times 2 is 10, times another 2 will give us 20. 20 cubic centimeters. And really what we're doing is the same thing we were doing when we were splitting this into slices or splitting it into layers. But to find how many are in each layer, well, we have 2 this way, and we have 2 this way. So we have 1, 2, 3, 4. 2 times 2 is 4. So there's 4 in a layer. We're finding that by multiplying 2 numbers together, the 2 and the 2. And then by the number of layers, which is 5. So then we're taking 2 times 2, which is 4, times 5, which will give us 20. So it just depends on which order we would be multiplying in, how we would cut that into layers. Let's try that again here. And I'm gonna draw in my dimensions again. So I have length. And then I have this way, width. And then this way is my height. My length is 1, 2, 3 centimeters long. My width is 1, 2 centimeters wide. And then my height is 1, 2, 3, 4 centimeters tall, 4 high. So again, I can move into that length times width times height algorithm. Length times width times height equals, that's going to give us our volume. So I'm actually going to, instead of a question mark, we're going to start to use variables. We'll put V for volume. And let's plug in our numbers. We have, for our length, we have 3 times 2 for our width times 4 for our height equals, and what's our volume? Well, 3 times 2, that'll give us 6. 6 times 4, that would give us 24. It would be 24 centimeters cubed. All right, let's look at letter C. We have length times width times height. And we have a length of 1, 2, 3, 4 centimeters. We have a width of 2 centimeters. We have a height of 4 centimeters. We do length times width times height, volume. Our length, and I'm going to put the centimeters in here, 4 centimeters times 2 centimeters times 4 centimeters equals, well, 4 times 2 give us 8 times 4 equals 32 centimeters cubed. Now, why we have centimeters cubed is when we do centimeters times centimeters, that gives us centimeters squared. So if I was looking for the area of just this surface here, I would do 4 times 4. I would do length times height. 1, 2, 3, 4, 1, 2, 3, 4. If this didn't have any width to it or any depth to it, I would just do this 4 times 4. Or I could do 4 times 2. I can find this surface over here. 4 times 2. Length times, or width times height. So if I did that, 4 times 2, well, this is going to give me centimeters squared. That's finding the area of one side. And then this 4 over here, so I have 8 centimeters squared times 4 centimeters. Well, 8 times 4 is 32, but if I multiply a centimeter squared by another centimeters, I'll get centimeters cubed. So that's how I get that 3 there. Centimeters times centimeters times centimeters. If I did 10 times 10 times 10, well, that equals 10 cubed, or 1,000. If I do centimeters times centimeters times centimeters, well, I don't have a numerical value on that, but that's going to be centimeters cubed. And that's when we're looking at volume, that's why we get centimeters cubed, not just centimeters. All right, let's do this letter D right here. So we have a length of 4 centimeters. We have a width of 3 centimeters. And we have a height of 3 centimeters. So I need to do 4 times 3 times 3. 4 times 3 right here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Times 3 equals 36. We get 36 cubic centimeters, or centimeters cubed. Number 2, it says write a multiplication sentence that you could use to calculate the volume for each rectangular prism in problem 1. Include the units in your sentence. I think we did that over to the side here, so I'm gonna go ahead and skip that one because we kind of already one step ahead of them there. Well, let's look at number 3. It says calculate the volume of each rectangular prism. Include the units in your number sentences. So it looks like we have a length of 4 inches, a width of 3 inches, and a height of 4 inches. And to find volume, what do we need to do? We need to do length times width times height. So we'll have 4 inches times 3 inches times 4 inches. Which equals 4 times 3 is 12. Times 4 is 48. That's going to be inches cubed that time, cubic inches, because we're not dealing with centimeters anymore. Now it says that our units are inches. Letter B, now we have meters. So we have 6 meters by 2 meters by 3 meters. So that's like a really big box there. We have we'll keep it the same. We're going to go length times width times height. But you can do it in any order you want because of the commutative property of multiplication. And we can do 6 times 2 times 3 or 2 times 3 times 6. But we'll keep it nice and simple. We'll do 3 meters times 2 meters times 6 meters equals, well, 3 times 2 is 6, times another 6 is 36. It's going to be 36 meters cubed, or 36 cubic meters. All right, and I think we'll do one more here. We'll do a word problem. Tyron is constructing a box in the shape of a rectangular prism to store his baseball cards. Has a length of 10 centimeters, a width of 7 centimeters, and a height of 8 centimeters. What is the volume of the box? So I'm going to do a little RDW strategy here for my word problem. So it has a length of 10 centimeters, a width of 7 centimeters, and a height of 8 centimeters. And I want to know what the volume of the box is. So I'm going to draw a picture of my box. So 8 centimeters by 7 centimeters. And the length is 10 centimeters. So it's going to be the longest that way. Key to making these, you want all of your lines to be at the same angle back. Might be able to do it a little bit better if you're a more talented artist than I am. But this will work for our purposes, and we have 10 centimeters this way, 10 centimeters long. It is 7 centimeters wide, and it's 8 centimeters high. Centimeters, not meters. And what is the volume of the box? Well, I have to do length times width times height, 10 centimeters times 8 centimeters times 7 centimeters equals, and I'm going to do 8 times 7 first because that'll be easy to multiply by 10 afterward. So I'll do 8 times 7, which is 56 centimeters squared, times, I'm going to bring this down, 10 centimeters. So just my area on this one side here would be 56 centimeters squared, times 10 more centimeters, which is my length, how many layers I have. And I'm going to end up with 560 centimeters cubed, cubic centimeters. So I'm done drawing, and I have to write my answer here. The volume is, I'll say the volume of the box is 560 cubic centimeters. All right, so that's where we're going to stop for today. Thank you guys so much for tuning in, and look forward to seeing you next time.